Now we're going to look at some arc and chord theorems. And so one thing is congruent central angles have congruent chords. Okay, so if I have a central angle, and I'll just draw one here, and a central angle starting from the center going to the edge. So these angles will have the same chord if their angles are the same size. Congruent chords have congruent arcs. An arc, remember, is what you measure on the outside from point to point. Congruent arcs have congruent central angles. Now, if a radius or diameter is perpendicular to a chord, then it actually bisects the chord and its arc. So the radius is bisecting this into two pieces. You can see the little congruent mark there and there. So you could say, if I had a point there, that would make it easier, that this segment is congruent to that segment. Now, the perpendicular bisector of a chord is always going to be a radius, or it could be a diameter if you extend it the entire way. Now, for example 4, I need to find QR, and they tell me that angle QPR is congruent to angle RPS. Well, since the central angles are congruent, then the chords have to be congruent. So I can set those two equal. 8y minus 8 equals 6y. So then I have more y's on the left, less on the right. I'm going to subtract 6y from both sides. Ignore that. That was just scribble. And 8y minus 6y is 2y. Minus 8 equals 0. Now this might freak you out. I've got 0 on one side. Well, I'm going to try and undo the subtracting 8 by adding 8 to both sides. So I get 2y equals 8. So now we're a little more comfortable, and I can say y is 4. Now, they didn't want to know what y is. They want to know the length of QR. So I'm going to substitute this 4 back up here. 8 times 4 minus 8, 32 minus 8, it's 24. And that is my answer. Now, this problem, they tell me that circle A and circle B are congruent. And this arc is congruent to this arc. So they want to know this angle right here, EBF. So if the arcs are congruent and the circles are congruent, then the central angles have to be congruent. Now this problem's a little interesting, so I decided to do it anyways, even though I'm going to get an interesting x answer. I have 45 minus 6x equals negative 9x. In this case, since I had the number just on one side, I decided to go ahead and add 6x to both sides. So I get 45 equals negative 3x. Well, x is being multiplied, so the only way to undo that is to divide. So I divide both sides by negative 3. And I get x equals negative 15. If you use your calculator and you go 45 divided by negative 3, you will get negative 15. And you're probably going, oh my gosh, that's a negative number. Well, they gave us kind of a weird negative thing up here, so it actually will work out just fine. I go negative 9 times the negative 15, and I get positive 135. And for our last example, we're going to find each length to the nearest tenth. Now, one thing I probably should have noted on these problems where you have the radius and you're making a right angle, you normally want to go ahead and make a right triangle. And I forgot to tell you to make that note on your notes. You want to make a right triangle with some of these. Now, if it's a diameter going all the way across and you don't know this value, and that's for like later sections, this doesn't always work. But if you know one of the legs and the radius, you can go at these using Pythagorean Theorem. So what I did is I said, aha, this one's 5. I know that this is 13. How did I know the radius was 13? Well, I went right here is a radius. 8 plus 5 is 13, right? So 8 plus 5 equals 13. That's the radius. So R equals 13. And I can put a 13 here. So I have that there. And then you can use Pythagorean Theorem, but you may be used to the 5, 12, 13 triangle, which tells me this side is 12. They want to know the length of RS. So all I had to do is add 12 plus 12, and I get 24. Now notice it says to the nearest tenth. Since it says to the tenth, I actually need to add a decimal and put a 0 there to have it be accurate. So for this next problem, again, I can figure out the radius is 70 because it's 20 plus 50. And I know there's a right angle. I know one leg, and I know the hypotenuse because I know this is going to be 70. So there's my right triangle. And the question is, they want me to find EF. So if I can find x, that will get me on my way. Use Pythagorean Theorem. X squared, and let me put my little right angle in there. X squared plus 50 squared equals 70 squared. So squaring out everything, 50 squared is 2,500, 70 squared is 4,900. Subtract 2,500 from both sides, and I get x squared equals 2,400. So I can say that x is the square root of 2,400. Now you could make this number look a lot simpler, but I'm trying to, I don't want to say simpler, but you can, they call it simplify the radical, pull out the square roots. But it's not going to really get you that much different of an answer. So I'm going to go ahead and just keep that as x. And I want to find EF. Well, EF is 2x's. So I just do 2 times the square root of 2,400. My calculator gives me a big, long number. I want to go to the 10th, which means my whole answer comes out to 98.0.